So hi everybody and welcome back to the C++ tutorials for absolute beginners. This is video 202 and in this video we continue with our linked list. And in this video especially we want to create a linked list again. And the reason for that is because in our first video, not the last video, but the first video, we created a linked list manually. What I mean with that is we have to write all time the first node, then assign the value, and then we have to wait at the second step here to create another node so that we can connect this pointer to the other one. And this step we want now convert, not this way, the whole step here, we want convert now to a function so that a function can do the job for us. And how we can do this. And I already showed you this picture here in Wikipedia. Here is this linked list which we created. And we displayed this, and here you can already see a code which we can use. This one is called add node, but actually it is really creating a linked list by adding nodes. You can start from scratch, or you can even add a node if you already have a list already. So what you can do now is, or what you should do now is, try to challenge yourself and convert this in C++. And the reason why I'm not doing this is because I watched around the web and I found a much shorter version than this one here. But short means not necessarily better. And to see what I mean, I want that you pause the video and try to understand this little code here. Because this little code here, you can see, that is the shorter version. Let's make it a little bit standing out. So this is the shorter version. You can see this here compared to this one. This one is longer, creates exactly this one here. This one creates this list too, but yes, like I said, try to pause the video and try to understand this little code here. If you understand it, very good. If not, no worry. It's not easy. It looks very simple, but it's really not easy for a starter. And I will explain this a little bit more in detail what happens here. So I continue now with the explanation. First of all, let's start. So what was our goal again? Yes, our goal was to convert this here to a function, and we want a function. And the first question is why we want a function. Very easy. For example, let's go back to our question. The question was to create a linked list, for example, this menu here, and let's say we are just creating these numbers here for score. If you have only 4 score entries, then there is not a problem. Then you could even use this approach without a function. But let's say you have an entry score here with over 400 entries or 4,000. To create here this manually, it's almost a waste of time, and that's almost impossible. It's possible, but nobody would make it. So that is the reason we need a function. The question is now, okay, how does a function can read 4,000 entries, for example? Very easy. There is another function who is, for example, a file reader. This file reader function opens a file where these entries are and just read the values here and call this function which we have to create, which is this one here, and enters all the values here, and this function here is creating the nodes. So that's that we should keep in mind, that we want all time as automated as possible, which means as less work for us programmer. So I hope you understand this code here. If not, now I'm explaining it step by step for you. So we are here, we are creating a function. So this one here, actually I call it a little bit different. Let's call it void. We know a void function means no return type, but it can change, depends on, perhaps we need a return type, but I call it create linked list. And this linked list, when it should be called, of course, where is that? I should enter the number, because that is still the condition that we should get an input data, which is our number, right? All right. So we know then, where is that here? We need a number. Let's call this int and call it number param. So, or let's make it here with the same here, like new data. No, let's make here our one, the number param. All right. I created here a function like this one. So what I'm doing here, and again, we are working here with pointers, and when we start to work with pointers, it is better to make a diagram because it looks very simple, this one. It is not very simple to follow, and that's why I use again this picture here, because we are creating again this list here just with a function. So the function should be able, when we enter here, where's the function? When we call the function here, let's call it, because now we have the function name, it was create linked list. So when I call here create linked list and I enter my first number should be 12, right? So when I enter my first number 12, then this here should create the first linked list. And when I add more, it should just add more to it. All right. So this is creating our linked list. And now we go step by step how this body is converting the thing. So what does the first line here? Let's see what happens here. First of all, it starts with a pointer. We know this is a pointer, right? All right, this is a pointer. We already discussed this node class. We still need our node class, which we also created last time. It is just this box here, which we have. All right, so let's create this one and make a diagram about it. Where is that? On top. All right, here, let's write it, node pointer. So I make a pointer and I call this new node, all right, like this other one on top. And let's make this in our diagram. What I'm doing here, I'm doing just creating a, till now, I just create a pointer, and let's make this pointer just like this. This is my pointer. So, and if you see this one here, it is this new node, but we will see how we make this, because it goes on, it says here, and now comes something new. And that's why I say it's not so easy. It looks easy. It's not easy for beginners. Here we use the keyword new node. All right, so this one is here. When you see the word new, you must be careful, right? We know what new is. New is allocating memory. Allocating memory means you as a programmer are responsible now to manage this allocated memory, right? So let's go back to our diagram and let's try to understand this first line here. What happens here? So first of all, I create a pointer. This is the first part. And this first part, this pointer is then assigned to a created node. It is again, it is this node here, but the only difference is about, let's say, about our manually created node, because here you can see we create here also a node, but this node is not a new node, it is just a normal node. This one is managed by the compiler, and this node here is not managed by the compiler, which means it is just a normal node. Let me make here this color here, which is again this box here. We know this box is our class. This class is called node, and this one here is assigned now. This new created node here is assigned now to our pointer. Let's make this pointer. I said the pointer is just this arrow here. So this is my pointer, and let's call, what is the name? New node. Okay, this called, the pointer is here new node. All right, and very important, the difference is now we have here this keyword new, and this one is managed by the programmer, this box here, right? Let's write managed programmer by you. Oh, I say here just managed by you, right? By you. You have to manage this one. So the compiler is not responsible for this one. And what we have learned when we use the keyword new here, right? So in our course, in one of my tutorials, I said when you see the keyword new, you have to use at the same time the keyword delayed. They come in combination. All right, let's write the keyword delayed. Delayed. Okay, I have to write it right. Delayed. And then what we have to delete here? It is this pointer here, because this pointer is the only access point to this new allocated memories. And we have to delete this later. The question is, wait a minute, why do we have to delete this pointer here? Why? What is the reason for that? And we talked about this when we talked about this keyword new, that when you don't delete this pointer, it will not release the memory. Careful, this delayed here means not you are deleting this pointer here. This delayed means you are releasing the allocated memory. This pointer here, this new node is still here. That is also a very tricky part here, so careful about this one. And the next question is, wait a minute. Here on top, there is no delayed node. I mean, this keyword delayed is here not used, right? Where is the keyword delayed here? We have just used here new. And I said when we use new, we should use delayed, but here in the scope it's not delayed used. So there is something wrong, right? Or I make something wrong. The point here is try to understand what's the difference about this and this. So if you understand this block here, sorry, if you understand this block here, then you know why here is no delayed. But if you don't understand the block, and let's say we are at this point, then we use this delayed. Let's repeat this again. What happens here? Here I allocate new memory. That is this point here. This is this pointer. It creates here this new node. This is this box here, and I have to manage this, yes. And when here I go out of the scope here, right? When I go out of this scope, what happens is that this new node variable which I created will be destroyed by the compiler. So which means when I go out of this scope, this created, let's make it here, don't know, red. This one will be destroyed. No, red is not good. Let's make it this one. So this one here will be destroyed when I go here out of the scope where I created this pointer variable with the keyword new. And when this go out of scope, then what happens is I have no access to this allocated memory, and this one causes a memory leak later. The question is now, okay, we understand this, we know this, we learned, or we have learned that. The question is still why they have not used here on top this new. So to understand this one, we have first go on through the code, and later we can still decide perhaps we don't need it or we need it. But at start, if you are a beginner, use it all time. When you see the keyword new, you use this delayed word, and later you can perhaps erase it if you understand that you perhaps don't need it. But right now we need it because this is the only access point to manage this one at this point. Let's go to the next line and see what happens there. All right, let's try to understand this one. It says here, let's copy the next line and make a diagram. Let's copy this one. Okay, I create this one. So I use the, this is the new data, that's wrong. I use again the new node. I have to assign here my param. This is this new number param here, number param. All right, next line. And let's say this delayed is not, belongs not to this group here. All right, so this line here says, okay, I use now this pointer. All right, I use this pointer. I point now to the number data, and we know what this number data is. We access the class. This is this class, and number data is this just integer value here. and we assigned the value which we want. And yes, at start you can see I assigned 12. That is exactly what I want. So I use the pointer here just to access the class and assign values. That is so a normal pointer use normally, right? Okay, then let's go on. I think this line is very easy and very clear. All right, let's go to the next line. Let's copy this one and paste this one in, and let's see what happens here. Here's something new. So we have here again the new node. That is this pointer, this orange one. This orange pointer is accessing again the class here. This is this class here. And this class here we can see has also a pointer. So we are accessing this class, this pointer here. Also our pointer is accessing this pointer. All right, that's cool. So let's make here another color here for this pointer here. So we are here now, right? Because that means if you go from this pointer to this pointer, that means you are here now at this point, because this is access specifier. And this one here says now head. We have to talk first about the head. What is this head here? The head here, you can see it's here again a pointer. We have again a pointer here. Okay, we know it is again a node. It is our node class again. So it is pointing again to one of our node class which we created or not. And this asterisk says it's a pointer. Till now it's a pointer. Let's make a color and make a pointer. Let's make here a color green. And this head pointer is pointing to null ptr, which means, let's make it so. This one is my head pointer. I call this one head. Oops, let's make an arrow. Head. And this one is pointing now to a null ptr. So first of all, before we go on, how many pointers we have here? We have here our new node pointer, we have our head pointer, and we have the class pointer. You have to distinguish these 3 pointers. You can see it's not so easy sometimes to track, and that's why they say pointers are not so pointers are not so loved, because are easy to be confused. But I think we are good on track, right? We see now all the pointers. Okay, let's continue with this line. This line says here new node pointer to node, which means first I start here, but when I access this one here, then I'm here. This is just the start point, right? This first tile here, first part here. I start from here. I use this pointer. This pointer is accessing this one. Now I'm here. And I assign this blue part here to what? To the head. So the head here is pointing at this point, at this time, I have to say, when I call this one, to null ptr. So I have to write here not this box here. I have to write a null ptr. With other words, we have to recreate this one. It is not creating this box here. It is this code here, what I have here, which is shorter, is not creating this box. Let's see what it is doing. So let's try to do this here again. So it is assigning this value 12. I assign it this side, doesn't matter which side. And this pointer, this blue thing here, that is this one, is pointing to this null pointer. Let's point it this way. And I say the head is here, similar like here. You can see my head is here. Oops. Make this so. And my head is here. It is still null pointer at this point. Null ptr. And this one, right? So this pointer, this blue part, this is this blue part or whatever, this part here. So this part is now pointing where the head is in this line. All right. I think we see this now, right? So we see, first of all, we see this is not creating exactly what we want, this little code what I showed you. And that was the first trap, I would say, where I said, do you understand this code? Because this one here is, let's see what it is creating, but it is not creating at least not that what we expected here, right? We expected here 12 first and then 99, but it starts here 12 and a null pointer, but we are not finished. Perhaps this will create this 99. So we can't say it is not creating. We don't know. But at this point, it looks not good. So let's see what happens. Then we go here to the next line. The next line says, okay, let's copy this one. Paste this one in, and now you see we accessing here the next line again. This head is a pointer, right? This is our head pointer. So where's the head pointer? The head pointer is at this moment here, and it is pointing to this null ptr. This is our green one, so I have to access the green one. All right, here I am, and now I assign this head again a new node. New node is a pointer. I assign, this is this orange pointer here. Now I assign this new node to this head, which means this head here is pointing to the same place where this new node is. And where is the new node pointing? The new node is pointing to this whole box here. Careful, the whole box here, which we have to manage, right? This is the thing which we have to manage. And let's call this, you see, this is the new node, right? I don't have all time to write it. And then this line here, this little line here says, okay, hey head, you should point there. And no, we assign now new node to head. So we point head to the new node here, right? And how we make this? We go from here in the next line, we go from here to here. All right, so this line here, this head says you point now there where this one is. And then, so the new node is, I hope this makes sense, but sometimes it's a little bit confusing. You can see we have to check, hey, wait a minute, where is pointing new node? The new node is pointing here. What we are doing, we are assigning the new node's position to head. Right, so the head should point now here where the new node is. I hope this is clear. If not, no worry. Just think about this one, and then this block is finished. So wait a minute, this block is finished. That was it, with other words, right? To test it, we have to go one step further because we don't see if this is really finished, because we need to create one more node and see how this works. Because right now we have made only the first step. We don't see, and my delayed node here is still not discovered what happens with this delayed node. If this is needed. Right now, let's say it's not needed, but we will talk about this a little bit later. But before we talk about this, let's create another another node here, this 99. Let's see if this is anyhow working. Perhaps it is working, or perhaps not. We will see. 99. All right, I create. So what happens here? I call the same function here again. This create linked list is called again. So let's start again. What happens? Before we start, we can see, oh, wait a minute. This new node here is created new, right? It is created here again. How is this possible? This is the first question before we create anything new. The point is this new node was created here locally, right? After new node exits here this scope, this new node, this orange one, is destroyed. And I said when this new node here is anyhow destroyed, and we have to manage this block here that can cause a memory leak that is normally very, very dangerous, right? And at this point, it is destroyed. So this new node is definitely at the end here destroyed. And when I call my second function, it will be created new, and that's only possible when it's destroyed. Because if it's not destroyed, I can't create the same here again anyhow, right? So anything. So what happens here is, let's see. The question is actually, have we a memory leak? I mean, this new node here, you can see, was pointing here. This was creating this box, and here our job is to manage this one, and this pointer is destroyed after the end of this box. How we access this one? And the answer is actually here. That looks a little bit strange, but actually what happens here is this new node here is indeed destroyed. This will be destroyed also here later. But this one here, this box here, it's not destroyed. Why not? Can you see it? It's a little bit complicated with my drawing, but actually there is something pointing to this box here. You can see this head pointer, which we created outside. We have shifted it from the null pointer position to this position, which means at this point, this orange one pointer is destroyed, and this head pointer still points to this location, right? So we have still access to it, and that's the point. That's the problem with this keyword new. You need all time anyhow an access to this place, and here was the trick, that this head pointer is now pointing to this one, and that means you can destroy this new node. We have still access through this head pointer to this one. And that's a tricky one, but like I said, this code looks very simple. It's not so simple to understand, but yeah, now I hope you understand it, that this one is possible. And let's go back to our delete node. Here, I don't need to delete this node here, and the reason for that is because this delete, when we use, the question is here, wait a minute, when does we use, when do we use here this delete? When we have no, when we want to release this place here, and we release it only when we have no more access to it, right? But right now we have still access to it, and we want not release it because we have saved the data in it. So we don't use here delete. And this is so the special conditions which you have to be careful, think through when you see this keyword new. And that is one reason why many don't like this keyword new with pointers, because that makes it so complicated. You have to be track what is pointing now to this location. Is there anyhow access? And I hope you can see that yes, this one is a little bit complicated, and that is one reason why many people don't like this. And that's why we will learn in future also the smart pointers, which helps us to manage this kind of stuff a little bit better. But I hope you understand now. At this point, we don't need delete, because right now we have this head pointer here. But let's see if this, perhaps we need delete later. Who knows? Because this one is still a managed storage. And at this point, we don't see any delete at all, right? So let's keep this delete here till we are absolute sure. But at this point, I hope you understand, we don't need delete because we have still access. So we go to the next function here. We go here to create linked list, and now I call the same function which we discussed again with just another number. And let's try it. So let's try it. So I call it here, and my new node was destroyed because I went here out, and now I start again, and I can create this new node again here, this here, because it was deleted. And let's create this 99. So, and again, it is a managed one. You have to manage this place, because I used this line of code, and this line of code, like before, it used the word new, and new means you have to manage this one. And this place is normally another new, right? This new and this new is not the same. And that means normally you need here another delete. Again, when you use the new, use again the delete new node. So we have another delete normally. So because that's the way. That's let's say that's the secure way to make sure that we have it at this point. All right, that was the first line. Okay, let's see what happens in the next node. Again, this created new node here is accessing the integer number data, which is this one, and we are assigning our param here to this one, right? All right, so this one 99 is assigned here. That's okay. And then what we do next is, again, the new node, this one here, is accessing this time again the pointer here, which is this blue pointer here, and this one is now assigning this to head. And I have to make again what I have to do here. Did I forget something? No. This one here is assigning this one to head. So the head here is here. So with other words, I should create again a new node here at the bottom to make it a little bit more clear. So let's create these steps here, which we had the first few steps here again here in this side. So I create here something, this box, oops, wrong color. Let's make this one so I create this box here. This is still blue. What's going on? There is color black. Okay, now it works. All right, so let's create this one here. This is the box. That was the new node box here. This time again, the number I write here. This is the linker. And you can see now we are here. We finished these 2 lines at this point. And now I come to this third line, which says new node here. Again, let's make the new node also here. It's accessing this linker now. And it says this linker I set to head. So let's see. This linker is this one here. And this linker is set to head. And now we have to check again. Where is the head? Head is pointing right now to this node here. To this new created node. So with other words, this one is indeed pointing now to this one here. Right? So we are pointing from here to here. Okay, that looks good because now they are connected. And now let's go to the last line again. And let's see what happens here. The next line says, okay, head is again our pointer. Head is this green one here. It is here pointing still here to this box here. And we set this to the new node, right? And this is the same thing what we did before. So what happens is, this is our new node here, right? And this one was destroyed. And this one is the new one, which we created in our second list. This one is our new node. So this head here is pointing there where it is. So with other words, here we have our shift. Oops, wrong color. We have here our shift again. So this here, the head here, goes here to the new points now to the new node. So it shifts here and here. And what happens now is interesting. We have still no delayed, right? We have no delayed here. But we have to check what happens here. First of all, we see that our head is moving, and this one looks anyhow good. Now it looks a little bit better than before, because now this number comes here, this number comes here. Head is walking. That was only a little bit side switching. But okay. But the question is, what happens next? Next happens, again, our head here, this head was very important for us. Why was it so important? Because I said we destroyed this first new node, which was managing our box. But this get destroyed, and then we instead used this head here, right? But this head is now moving away from this one which we have to manage. So the question is, oh, what? This one is moving from here. And can we manage this one? And the answer is yes, because now, look this, we have still an access point, this one here. This one here is still accessing this memory from this pointer here. Can you see it? That was this line here where we connected this pointer to this node here. With other words, this green pointer head can move because we have here access, and this can again be destroyed because, let's see, because on my next call, this one here, after this one, we go out of scope. You can see this is this place where we go out of scope. This one gets destroyed again, like all time. Oops. You know, when we go out of scope, we go destroyed. The question is, hey, wait a minute. This one gets destroyed, this head. Okay, but why isn't why the head is not destroyed? Because head is a pointer too, right? And it's very easy. Look this, what happens here. This new node, this orange one, is defined in this scope. And when we go out of scope, this new node variable gets destroyed. But look where head is defined. Head is not defined in the scope here, which means head can't be destroyed. When we go here out of scope, that means head is all time available, right? And when I say destroyed, sorry, yes, here it means destroyed, but don't get confused with delayed here. Destroyed and delayed are different, right? Delayed means all time release of memory, and destroyed means really this variable is erased. All right. Okay. That's that. So we understand now that this head is not destroyed because it is not declared in the scope here. It is still present, which means we have this head here. And interesting is we created now here this new managed box here. This one is all time. This orange one is just creating all time a new node, right? This orange here at first creates a new node. Then the head takes over, which means the head points now to this new node, and then this new node pointer can be destroyed. Then the new node here creates again a new node. Then the head takes over, but before that, it is assigning this place here. Very important is after we create a new node, this one must be assigned because now this here is our new access place, which means when you follow this one, when you want call this one, you have to start from the head. So let's say I want call this little list. So let's say I want call this little list here, which I created here with these two things. How you can call this one? The only way you can call this one is by using this head here. And the question is why? Because this is the only access to our memory which we created. And this memory is the only way to access the second memory here. Because we have here only this one access point, right? And yeah, I hope you understand this. And if not, don't worry, it's not easy. Try to make it all your own drawings and try to understand this. And the next thing is what I want to talk here is, again, why we have no delayed. Because I said all time we need to use a delayed. And the reason is very simple when we think about it. As long as this head here, you can see this one, has access to this memory, and this head is anyway defined outside of this one, and this one gets destroyed when my program terminates, right? So when my program is closed, then this one will be destroyed. And then we have no more access to this point here, which means This one would cause memory leak normally, but careful. When our program terminates, then all the resources go back to the operating system, which, for example, Windows, and Windows will, in my case, free this memory anyway. And that's why we don't need here this delayed. And that's not easy to understand, and it's a little bit tricky, but yeah. I hope you understood it a little bit. If not, no worry. It is anyway training and we should it is more a pointer training that you start to see how to use pointers and what they are doing. As a starter, it's more, and that you also see why many people don't like pointers, because you have to track what you are doing, especially very dangerous all time this keyword new. When you see a new, then you have to be careful, and that's why I said when we talked about this keyword new, in future we will learn other ways to use pointers, the smart pointers, or there are classes memory management classes, which is better, just because it's very easy to make here a mistake, right? You can see this is a little code. You can see this code is really little, but there is a lot of things which you have to consider. And to explain why we don't need here delayed, you can see that was the explanation what I gave you. We don't need delayed is here simple because it was all time we had, also in short, we had all time a way to access it. And later when the program terminates and this last access point is destroyed, then the Windows will free this memory anyway, because this goes back to the operating system. And that was the knowledge which you really need here. And then tracking these pointers. And here is one more thing, the last thing. This shorter system is actually not so good like the other one, which I showed you here. Question, why? It looks similar. You see, we start here 12, 12, 99, 99. But here is a problem, a big problem when I want to display this. What is this? Try to figure it out if you want. It's difficult for starters. It's not easy to see. But I give you a hint. Think about how you would print out this here. How you would print out this one. And then, okay, I go on and explain it now. The problem is this one print out the list not in this order, the backwards order. And the reason for that is because I said this head is the only access point which we have later. You can see this head is the thing which we have to use, this head pointer, to access the first or let's say the last memory which we have added. And then we have to go from this pointer, use the access pointer here, go back, print this out, go back, print this out, and so on. And this one print out all our things backwards. So this short version, what I showed you here from the web, which I took it just from the web, it's actually the question, is this better or worse than this version here? And I said, like I said, you should challenge yourself, try to translate this one here, because this here, what you see here down, do the same thing here, but here in this version you will have a list which is indeed going from 12, 99, 37. And when we go here and finish our linked list, let's make here create linked list. Let's write the last number is 37. Okay, let's write 37. And here is also a display, and this display is similar, like it's just not similar, but it's made for this one here. And when I print this out now, you can see these numbers here are let's see, we have here 12, looks good normally, 12, 99, 73. Of course, if I call display, I have to call the display here and not my print linked list. That's why it looks good. That's not the thing. This one I have to call display. And this display is actually, in short, this display here. I will not talk it now because the video is too long, but in short, this display function here is taking the head. Like I said, we have only access to this managed memory through the head, and then it prints out the value, goes here, prints out here the value, and it goes here from this class linker. Yeah, here, back from here, it access this, goes here, then goes here and print this. And that's the problem, because the problem is now when using this head pointer, it is printing this backwards out. Right, you can see now the code is printed out backwards. It is shorter. So when you are going to create now this code, try to challenge yourself. I will show you the solution in the next video. If you create this code, this one will print it not backwards, in the right order. So the question is now, wait a second. Make it sense to use then this one here, or makes it sense to use this one here? Which one is better? This is the interesting question here, right? And the short answer is, it depends. Sometimes this one here is very good, but there are cases this one is better. Even this one take more time later. And the short answer is why that? Because perhaps you need the entries like they come in. What I mean with that is you want this order here, exactly this order. Let's say you have whatever reason you need this order here, and it must start with 12, 99, 37. Then perhaps you say, okay, I can use perhaps this one here, perhaps. But let's say you don't need this order here, right? Let's say I don't care about the order. For example, in our case, in our example here, let's go back here. In our example here, we don't care about the order. Why not? Because I said we will make a sort algorithm anyway. In our case, this version here is better because this will take less time than this one here. And later we use this, we create a sort algorithm anyway, and this will be sorted, then depends on the score or whatever. But like I said, let's say you get an ordered list from the start, then you don't want to waste time again inserting them and ordering them again. Perhaps I don't measure the time, how much time this costs. I don't know this exactly, but could be that you would then use something like that, because this is using the order in the right way from start. So that was a little bit much talk, but I hope you can see how a little code like this one can be not so easy to understand for beginners, not even for even at once people get confused. And that's why, like I said, that's why we in C++ they created this new pointer classes, this smart pointers and this helper variables, because this pointers and this allocated memories cause big problems. And I hope you could see it, this little code already to explain. Yes, it was also not so easy, but I hope you understand it a little bit. And with that said, I stop this video, and don't forget, challenge yourself perhaps and try to translate this code here to C++. It's almost finished, because you have just to find the right, I think most of them are pointers instead of normal nodes here. And then you have this one too, because next time I will show you just the solution here, and yeah, then we will implement this there. So if you have any questions, any suggestions, like old time, write it in the comments. See you in the next video. Bye, good luck, and like old time, never give up and have fun.